Hello everyone. In this video, I will be introducing first with my beloved younger colleagues who are posted in graphite exploration, and why I am going to introduce them because they are doing exceptionally good job, and I myself was also I'm getting inspired from their dedication, and I always used to motivate others, and self motivation is also required. So why I am going to introduce, because since they are associated with graphite exploration in Lindi area, Tanzania, most of the times whenever they get time, they used to take travels to understand the regional geology as well, and often they interact, they send some good feed photographs, and often they try to know what is the significance, what is the reason behind that. Anyway, they are Mr. Animesh Mondal. This is their LinkedIn profile, and so he is junior manager, and Somodeep Das, he is assistant manager, and both of them are having good academic background. So with this video is dedicated to them because they have supplied nice field photographs, and based on that I have got some scope to discuss a significant topic on importance of garnet. Let's start. So mostly, if we see the area, see this first photograph is an outcrop photo. In close view they have taken how beautifully garnet has been found to grown. You see biotite flakes are also there, and quartzophosphatic materials. So clearly you can see nicosity as well as nice foliation, color banding, and within that garnet has been developed, which is indicative of in general medium to high, very high grade, but depending upon the type of garnet, grade of metamorphism is different. Actually, garnet is a group of silicate minerals, and mostly it is an important indicator of metamorphic condition. But having garnet itself always will be indicative of very high grade metamorphic condition. It is not like that, because it depends upon the type of garnet. For example, pyrope, almandine. Pyrope usually occur in very high grade, very high pressure temperature condition they grow. You will have to understand the composition, chemical composition as well. Understood? Based on that only, that formational stability, pressure temperature condition will be determined. For example, almandine is also indicative of relatively high and high pressure temperature, but not like pyrope. Always remember, pyrope form at highest degree grade of metamorphism. Among all other garnet, pyrope is indicative of highest grade, highest metamorphic condition, highest pressure temperature condition. Okay, so since they are working in Lindi area, that is situated in Tanzania southern part, there East African orogeny is very much common phenomena, and locally it is also called I think East African orogeny, or I forgot the name actually. When I remember, I'll tell. It is equivalent to broadly Neoproterozoic Pan-African orogeny, Mozambique orogeny. Yes. So understanding the rock types and geological history of the Lindi is crucial, because geological history of Lindi area is influenced by the Neoproterozoic East African, which is equivalent to Mozambique or Pan-African, or in India it is also known as locally Eastern Ghats orogeny. They are almost equivalent. Okay, so these orogeny led to the formation of extensive metamorphic belt and associated graphite deposits, and grade of metamorphism often varies from granulite to greensist metamorphic phases. Now, in this Lindi and surrounding area, if we see the rock types stratigraphically, basement rock comprises of primary schist gneiss, in which that graphite mineralization is observed, and mostly they are situated. These outcrops are observed nearby Masasi, Niwala, Liwale, Nachingwea districts, and remaining other parts there are patches of sediments which are younger, mostly Jurassic to Cretaceous. Tendigiri Formation is Jurassic to early Cretaceous, which is very much famous for well-known dinosaur fossils, where is some important heritage site is also available. And above that, Lindi Formation, that is late Cretaceous. So Tendiguru is very much famous, but our objective is, since our objective is to find graphite, so we'll be confining in these basement rocks where we can see grade of metamorphism varies from greenschist to mostly amphibolite to granulite. That places upper greenschist species is observed. And rock types is mostly quartzofelspathic rock, schistose rock, often show feebly developed gneiss and at gneissic portion or high grade granulatic portion, it is that gneiss is much better developed with prominent color banding. And now see this beautiful hand specimen photographs showing that alternative color banding, how beautifully it has grown due to that orogenic event. That orogeny lead to formation of intense folding during east-west compression uh, of that East African orogeny. What happened? North-south fabric got developed. North-south, it varies northeast southwest at places. So in this area, mostly northeast, yeah, northeast southwest like strike, and these are developed due to intense tied to isoclinal folding related to thrusting. Okay, so axial planar cleavage has been developed, and that foliation further used lead to generate gneissic foliation, gneissosity, due to partial melting or anatexis of the quartzofelspathic materials which plastically started flowing, and along the weaker zone they accommodate themselves, and accordingly such banding has been formed. It is very well known, a very common features. It is, you can get in any structural geology book how gneiss forms, simple during folding. Okay, another gneissosity is developed, often called lit per lit gneiss, along foliation weak zone when quartzofelspathic materials come up. So that foliation material must be of relatively melanocratic, that means some muscovite, biotite, mostly biotite rich. But here it is fold related. Okay. Now, since so much garnet, well developed udral crystals are developed, genuine question arises what type of garnet these are and how did they form. So if we want to solve that question, we must understand a few reactions and what are the associated minerals apart from garnet. Garnet is secondarily grown during high grade metamorphism, but how that essential elements has been supplied from what source. So this, if we see this association, mainly quartzo-feldspathic material, which is for giving that lighter tone, and biotite. That means muscovite also might be there. Muscovite might have broken down because these types of garnet usually form often during breakdown reaction due to high dehydration. Okay, hydrous minerals gets broken down and water release and dehydrate minerals like garnet forms. Okay, so let me introduce this major 5 reactions first. Chloride plus quartz, garnet, biotite, water. So biotite and garnet will be available. Here you see garnet and biotite common and quartzo-feldspathic material is common. And muscovite and chloride must have gone away due to reaction. So it is most likelihood like that equation which usually occur in 10 to 15 kilometer depth corresponds to 0.5 to 1 gigapascal pressure, 450 to 550 degrees Celsius. And another reaction often may happen, biotite plus plagioclase plus quartz. That also lead to form garnet K feldspar water. Another one, muscovite plus quartz plus chloride. There are n number of reaction is possible. I have shown only 5 For example, the point is that first let me introduce all the type of garnet, then automatically easily we can understand which type of garnet these are, because almandine is usually formed in medium to high grade metamorphic rock where iron must be supplied, aluminosilicates can supply aluminium, and remaining silica from quartz. So since our rock type is biotite rich, okay, then feldspar and quartz is also common. So and regional metamorphic setting of schist gneiss terrain along with mobile belt or orogenic belt is good setting for almandine. So there is chance of getting almandine. Whereas pyrope is high to ultra high metamorphic condition. Usually pyrope is developed, and high pressure rocks, eclogites, peridotites. But of course, pyrope is also possible to get in this type of terrain as well. But apart from these, grossular, spessartine, andrite, and uberite, they are low to medium grade garnet. They don't require very high temperature pressure condition. Mostly, grossular is formed in contact metamorphic setting, like androdite as well. They are calc-silicate setting where calcareous materials are intruded by granitic material along that contact site. Often these kinds of garnet is available. So we can easily uh, deduct these two possibility. There is no chance of getting grossular or androdite. What remain behind? Spessartine and uvarovite. Now spessartine is manganese-rich sedimentary rock and schistose rock. In such type of rock, spessartine often observed. So there is no question of getting Mn-rich sedimentary rock which got low-grade metamorphosed. It is not likelihood. And uvarovite is also not possible to find here because it is found in ultramorphic type rocks of low-grade metamorphic, low to medium-grade metamorphism. Because chromium supply is required. Chromite-bearing rocks like serpentinites are most usually observed source for uvarovite. So only two options left behind is pyrope and almandine. Now further let us see what may be the possibility. Here again you see how good well developed crystals are there, and as I have told, high grade metamorphism used to give grain size enlargement. Okay, so pyrope forms at high pressure metamorphism in eclogite and peridotites at subduction zone and deep crustal setting. And almandine is formed in medium to high grade regional metamorphism in pellitic schists in orogenic belts. So if we see these two possibility, to my opinion, more likelihood is almandine, because there is no pyrope is further higher condition, higher temperature pressure condition, in which orthopyroxene also must have been developed. Since here in these rocks, orthopyroxene is not as such observed. So, to my opinion, these are mostly andradite, which is also very much common in present setting, like convergent setting where orogenic movements has been found. That signature, it is of course East African origin, as I have told. Now spessartine, it is not possible because it is Mn rich schist and contact metamorphic zones are required to develop spessartine. Like grossular, then again skarn, it is not possible. Uvarovite, as I have told, ultramorphic rock is required, it is not possible. And finally androdite, that is also not possible because contact metamorphic setting iron calcium rich rocks is required, which is not available in this area. So based on all the observations and evidences, it is quite clear that these garnet are most likely of almandine category, because almandine garnet in general form at medium to high grade metamorphic rocks at orogenic belt, and dehydration reaction during breakdown of hydrous minerals like muscovite, chlorite, biotite are very common in this area. So such dehydration reactions are further, we could say that these are very much important, as fluid release during such metamorphic condition further react with other minerals in hydration and thereby play significant role in rock evolution. So that is the importance of fluid. Finally, if we see at a glance different type of garnet and respect a few reactions out of different possibility, I have just kept few reactions for representative category, representation purpose, and corresponding pressure, temperature, and environment condition. So based on this, you can skip, you can pause this and see. So for detail, you can easily understand that these garnets are of almandine category, which are very much common in regional metamorphism in schistose zone at orogenic belts and form in medium to high grade metamorphic rock during relatively higher pressure temperature condition ranging from 500 to 750 degrees Celsius, and pressure condition is 0.5 to uh, 1.2 gigapascal. And of course, chlorite, biotite, and muscovite are main supplier of almandine. They got broken down during their main hydrous minerals, and of course chlorite start breaking down at the beginning, then muscovite, and muscovite usually break more readily than biotite. Okay, so that's it. I hope you enjoyed. And here this table also must be remembered every always, because this is at a glance giving the overall comparison. Here always remember the most problem what you can encounter in such terrain is between pyrope and almandine. Okay, but you remember almandine is more common than pyrope, because to get almandine pyrope, more higher temperature pressure condition, highest grade of metamorphism is required. Among all other garnet, pyrope is formed at highest grade of metamorphism and temperature condition, as I have told, 600 to 900, whereas almandine is relatively lesser temperature condition, 500 to 750, and crustal depth requirement is 15 to 30 kilometer for pyrope, for almandine, and for pyrope always more than 40 kilometers. Here also we can see this pressure conditions of 1.5 to 2.5. Here 0.5 to 1.2, 1.5 to 2.5. Okay, and here 1.5 to 2. Okay, so that's it. I hope you understand.